11, lesson 6, the Pythagorean theorem. A theorem is basically another word for a theory. It means something that seems to work, it seems to be true. For example, gravity is a theory. We think the reason we don't float away is because of something called gravity. We're pretty sure. Pythagorean is an adjective based on the person who came up with this theory or theorem. His name was Pythagoras. He was an ancient Greek mathematician. And this is all about triangles. We have not done geometry this year. So the first thing I want to remind you of, not what a triangle is, I hope I don't have to remind you of that. I want to remind you what a right triangle is. It's a triangle with one right angle. The right angle, of course, being marked by the little square, right angle, 90 degrees, perfect square corner. And the Pythagorean theorem only applies to triangles that are right triangles. And the reason we're throwing this in here is because it has to do with exponents. And we're also going to put in a little bit of radicals, of square roots as well in order to solve these. So that's how that fits in. And you'll see it as we get into it. Now, what we're going to be doing is talking about the length of the sides. If we were to measure them with a ruler, for example, right? So the length of the three sides. First of all, we're going to be labeling them with A, B, and C. The Pythagorean theorem always uses A, B, and C. So you won't see other variables for the most part here. Because there's actually a kind of a pattern to it. The C is the most important one in terms of its placement. The C, the side that we label C, is always the longest side. And just a reminder, you don't have to remember this for this lesson, but in geometry, the longest side of any triangle is always opposite the biggest angle. In a right triangle with this 90 degrees, this is always the biggest. Because the angles in a triangle always have to add up to 180. And if this one's 90, these two have to be less than 90 each. So the C is the longest side, always opposite the right angle. And this has a special name. This side is called the hypotenuse. The hypotenuse, also a Greek term, probably suggested by Pythagoras. So again, the important part is that the hypotenuse, or the side that you label C, is always the longest side, which means it's always the side opposite the right angle. Now, here is the actual theorem that Pythagoras came up with. If you square the length of side A, and you add that to the square of side B, the length again, it will equal the square of the length of C, the hypotenuse. A squared plus B squared equals C squared. Here's the formula that we're going to be using for this lesson. So, let me give you an example of how it would work. Sometimes this will be done in words, sometimes you'll be given pictures, sometimes you'll just be given the information. If it helps you to draw a picture, we're going to draw a picture. So for the first one, we'll just draw a quick picture. The information, the length of one side of a right triangle is 28 centimeters. The length of the hypotenuse is 53 centimeters. Oops, sorry, that should be, let me rewrite that, 53 centimeters. So it said hypotenuse, so guess what I know? I know that that's the C side. Write and solve an equation for the length of the unknown side. Now, first of all, let me just come back up to the formula real quick before we finish this one. If I switch the order of A and B, would it matter? Let's say I named this one B and this one A. Diego, why not? You're right, it does not matter. Because we're adding, and we can add in any order, right? So that's important, first of all, that the A and B, it doesn't really matter which one is which, as long as C is the hypotenuse. So it doesn't really matter if we want to call this 28 to be the A or the B. To keep it the same as that example above, we'll say that A is our unknown. But again, it doesn't actually matter which one's A and which one's B. C is the one that matters. So let's write an equation, and then we'll find A. Well, equation is going to be based off the formula. A squared, oh, I don't know A, so I'll keep it as A squared. B squared, well, I know my value of B, that's 28. Equals C squared, okay, I was given the hypotenuse, that's 53. And now we're going to use our calculators. According to PEMDAS, we need to do the exponents before we can add. So 28 times 28, I get 784. 53 times 53, 2,809. Now, to solve. What am I going to do to solve? What's my first step? Izzy?
Subtract 7.
Good. We leave the A alone, leave the variable alone, and undo the other operations first. So 2809 minus 784, A squared equals 2025. Okay, I don't want to know A squared. I want to know A. We're always going to be asked to find, most of the time, the missing variable, and that means not squared, just the length of that side. So this leads us to what we were doing yesterday. How can I find what A is? Brian? Okay, good. If I want to undo the power of 2, the opposite of that is the square root symbol. Square root of A squared, those cancel out, leaving just the A. Now, again, for this side, you can use your calculator now to check and see if it's a perfect square. If you do that, you will discover that this is the perfect square of 45. I don't need you to know that by heart. But if you were to type this, let's say instead of 2025, let's say it was 2030 was our number. And you take the square root. If you get a decimal, this is 45.05552. If you get this, then it's not a perfect square, and then you have to go back to the method of what perfect squares might be a factor here, and you start to break it down. Now, technically this morning I was saying, hey, it could be a plus or a minus. Could this be a length of a negative 45? Good, I see lots of thumbs downs. You're not going to have a negative for a length. It's just a length, it's not a negative. So for this, because we're dealing with actual lengths on a shape, we're not even going to worry about the negative possibility for that number. Okay, so here's the idea, is that out of these 3 items in the theorem, if you know any 2, you plug the values in for the 2 that you know, and you solve to find the third one. The only other type of question you're going to see, other than working with different, they'll give you, this time we were given the B and the C, you might be given the A and the B, maybe the A and the C, it'll change for the different problems. The other type of problem you're going to see is, could the 3 numbers be the lengths of the sides, my blue pen is dying, of a right triangle? So you'll be given 3 numbers, and the question is, could the 3 numbers be the lengths of the sides of a right triangle? And really what they're asking is, would these numbers make a true statement with the Pythagorean theorem if we plug them in? Because if they make a true statement, then we could have a right triangle with these lengths. If they don't make a true statement, if they don't plug in, then it means that these 3 numbers could not form the sides of a right triangle, because any right triangle should fit this pattern for the Pythagorean theorem. Now, we have to test them out and see if it makes a true statement. How do I know which one is my C? Because that's the most important one to know. Christina? The biggest number, exactly. C is always the biggest number. It doesn't matter which one is A or B, so again, I'll just keep them in order. There's A squared plus B squared equals C squared. And all you have to do for these is do the exponents, test it out. If it's an equal amount on each side, then the answer is yes, these could be the sides of a right triangle. If you get two answers that aren't equal, then the answer is no. These could not be. So let's try it on this one. 16 squared, 16 times 16, we get 256. 24 times itself, times 24, I get 576. 30 times 30, I can do that, mental math, 900. So now I add 576 plus 256, and I get 832 equals 900. Well, that's not true. So could these be the sides of a right triangle? No. If I got 900 equals 900, then yes, hey, the Pythagorean theorem works. These could be the sides of a right triangle. Thank you. Okay, so that's it today. Either finding the missing side, the A, the B, or the C, or telling whether the three sides could make a Pythagorean, make a right triangle using the Pythagorean theorem.